John Carl Friedrich Gauss, country of origin, Germany. Germans have always been the leading innovators in both technology and science. Their mathematician's contribution to this field is quite significant. It was a German mathematician who first established the principles of the law of gravitational pull, demonstrated that mathematicians is just an assumption without evidence, and introduced us to aerodynamics. Famous mathematicians from the nation include George Friedrich, Bernhard Riemann, Johannes Kepler, and Gottfried Wilhelm Leibniz, who contributed to the world's first theories of calculus, analysis, and differential geometry. The world would have been different without these theories, which served as the cornerstone for numerous scientific advancements.
Upbringing/intro to math.
Gauss was the only child of impoverished parents. He had a talent for languages and was a prodigy in math. The Duke of Brunswick approved financial aid for him to pursue his schooling locally and subsequently to study mathematics at the University of Göttingen. In 1791, after receiving recommendations from his professors and dedicated mother.
Contributions to math.
The fundamental theorem of algebra, according to which any non-constant single-variable polynomial with complex coefficients has at least one complex root, was established by Gauss. In addition to developing the ideas of binary and ternary quadratic forms, he made significant contributions to the number theory.
Relation to AP stats. Bode's law, the binomial theorem, the prime number theorem, the arithmetic/geometric mean, and the law of quadratic reciprocity is only a few of the significant findings in number theory that Gauss was able to derive on his own.
All right, we have FRQ number 4 here, and this is our way of doing it at the E level. So we're going to start off with state, which to start off, MD is going to equal the difference, which is just placebo minus omega 3. And then we're going to do our hypotheses, which for this problem is HO equals MD equals 0. And then our alternate is going to be MD is greater than 0, which all this is a match pairs t-test. So now we're going to move on to the plan where we show that it's random because it's randomly assigned in the treatment. Each person gets randomly assigned the drug. And then for the independence, we're going to use the 10% rule. And the 19 participants is less than the 0.1 of all people with the condition that's being treated. And to prove that it's normal, if you look at the graph with the box and whiskers, you can see that there are no large skews in the graph, which shows its normality. And then once we move on to the do section, we're going to move over to the calculator. And we're gonna go to stat, over to test, down to t-test, which is number 2.
Huh? Keep it this way.
Okay.
Not like that way. Because I'm recording it backwards.
So their input is gonna be stats. Your mean for this is still gonna be 0. Your statistic is going to be 1.789. Your standard deviation is going to be 2.485. The N, the sample size is 19. You're going to make sure you have the greater than selected. You're going to click calculate, which will lead you to these statistics, the test statistic of 3.138 and a p-value of 0.002842. So now moving on to the conclude, we're going to say because the p-value is greater than the alpha value, which is 0.05, which we should have included over here, we're going to reject the hypothesis with convincing evidence that omega-3 supplement reduced the mean irritability score in these adults similar to the ones in the study. Okay, so for partial credit on the number 4 of the FRQ, you'd be missing the designation of what kind of random, so you'd get rid of the random assignment. Just say it's random. Probably wouldn't include the graph part. You wouldn't have had the test, like said what the correct test is, so you would, to show how you came up with these statistics, so you wouldn't have said the correct test, and your conclusion would be without context. So this all context right here would not be there in a partial for question 4. Further, if you were to get an incomplete on FRQ number 4, you'd be missing all of your important statistics. Your hypothesis would probably be inaccurate. You wouldn't have used the correct 10% rule. You would have just said independent. And there would be no with convincing evidence. If you were missing all that, it would be incomplete at that point, and you'd be looking at an I.